Hello, everyone. I'm Zohreh. I'm talking about goal monitors today and the relationship between interpret, plan, act, and perceive. This is MIDCA architecture, just a cognition phase, as you saw in other talks today. I just want to mention that MIDCA has 6 different phases, and my work focuses on these 4 phases: perceive, interpret, plan, and act, and the relationship between them. And I will explain how interaction between these phases help the agent to accomplish a task successfully in a word. My research plan focuses on how an agent can respond appropriately to a dynamic word. A dynamic word is when the changes might happen in result of other external events, and that can affect the agent's goal and tasks. Last year, we reported integration of planning and perception using plan monitors. Plan monitors guide vision to focus on features that only affects the plan. And if any changes happen to those features, then a plan refinement will be done in response. The but replanning or plan refinement is not only the solution for the problem. Sometimes the agents need to alter its own goal to be able to successful. So we use goal monitor here to focus on changes that affect the agent's goal, and these goal monitors track that the goal maintain its usefulness, and we'll see if it needs to pursue the goal. In plan phase, planning begins to find a sequence of actions to accomplish the selected goal. Plan monitors are generated during the plan phase, and they focus vision to only monitor the features that affect the plan. And if the perceived state differ from the expected state, which is the preconditions of the operator, which if they differ, then it leads to plan refinement or replanning. Then the act phase begins with when the planner finds a valid plan in the current state. And so this is part of the future work. We're gonna use the plan monitors during the execution part to see if the condition of operator are different from the agent expectation, then it results in replanning and plan refinements too. And then monitors observing the conditions of the goal, and if those conditions are not valid in the states, then it leads to goal transformation or goal abandonment. A goal reasoning agent has an explicit representation of goals. It is able to formulate their own. They are able to formulate their own goals. As Mike said before, so MIDCA is not waiting for the person to tell what goal to choose. It can reason about its own. It can reason about and generate their own goals. So there are 2 different ways in MIDCA that can formulate the goals. First, there are some rules, and each are some conditions, and if they are valid, then a goal is generated. The second part is a discrepancy happen. The agent's expectation is different from the perceived board, so and it detects a problem and it tries to explain it, and based on those explanation, it formulates the goal to remove the cause of the problem. So and a goal, and then these agents are able to manage their own goals and select which goals to pursue. Uh, there are some cognitive architecture like Icarus that use rules to generate goals, and so in this kind of methods, the current condition trigger what goal to select. And some other approaches like I guess PUG use numeric utilities associated with symbolic goals, and they generate dynamic utility, and that's how they select their goals. And another example is MR2, that using domain independent motivation way to select goals. So we say that the reason to select or formulate goal should be monitored, and also the reason that affect the goal selection, if you monitor them, it helps us the goal selection too. We categorize our goal monitors to operator style and explanatory. The operator style, when the goal is generated based on some rules. So we observe the preconditions of the goals, and if any change happens to those preconditions, the agents decide to transfer the goal or abandon the goal. Explanatory is when the second type, when goal is formulated based on an explanation, and then this goal monitor observes the causal justification, and if the reason changes, then it abandon the goal. So in MIDCA, interpret and when it adds a goal to the set of pending goals, it create monitors for the reason that it lets the agent to choose that goal, and these monitors will specify what to monitor in the state, and then if any change happened to them, then the monitor fires, and it remove the goal from the set of goals, and also if in the middle of planning, it notify the planner too, and the planner doesn't need to generate a plan for that specific goal. Here, a piece of code that I put here, that it explains when the preconditions of a goal is not satisfied in the state, then it results in dropping the goal. This is an interpret phase in MIDCA. You don't need to read the details here. So just want to say, in the first part, it checks to see if any monitor fires, and if it does, it abandons the goal, and it removes the goal from the set of goals it has, jihad, as you can see here. And when it formulates a goal, then it create goal monitors for that specific goal. This is an example for operator style. Here, you can see that this is our goal. This is the goal operator that we have, and the preconditions is a package exists in a warehouse, and an order exists for that package, and if they are met in this state, then a delivery goal will be generated to deliver the package to the destination. And we monitor those conditions, that an object exists in the warehouse and an order exists in the warehouse. See here, this is an example that the package P1 that has to deliver to D1, and this package exists in the warehouse, and this goal is generated. But when package 1 is stolen, then interpret will the goal monitors will remove that goal from the set of pending goals. We ran an experiment in logistics domain. The initial state is we have n warehouse and 5 packages in each, and 1 order exists for each package. The x is the number of warehouses, and y is the performance, how many goals is achieved by MIDCA. As we can see, the MIDCA with goal monitors has a better performance than MIDCA with no goal monitors. For example, when we have 10 packages, and I forgot to say that during runtime, six packages from different warehouses become lost. So here, goal monitors can detect the changes and remove the related goal from G. So here, as you can see, when the number of warehouses is 10, the number of goal achieved is only 20, because only four for warehouses will be achieved, and is less than MIDCA with goal monitors. So show that the integration of interpretation, planning, and acting in a cognitive architecture MIDCA. And as we saw, using goal monitors increases the number of goal achieved. The future where will be, as I mentioned, we want to use the plan monitors in execution, and also if when a monitor fires, the agent should reason about it, and because sometimes it reason about it to see if it needs to respond to that change or not. And also explanatory goal monitors, we need to work on that. Is still in the we still like the preliminary base, so it's just like the first steps on that, so we need to explore that part. And also we want to use these goal monitors in human robot interaction. When a human asks a robot to do something, the robot needs to know why, and based on that, and monitor that reason to be able to if it needs to pursue the goal later or not. And also when a goal monitor fires, the agent needs to decide to abandon the goal or transfer. For now, we simply drop the goal, but later we wanna reason about it and see in which conditions the goal needs to be abandoned or need to transfer to another goal.